Hello everyone, welcome to a new video. We are going to talk about various asymptotic notations that there are in terms of coding. So there is, obviously you would know, there is best case, there's average case, there's worst case. And I know that you would know all of this, but there's a slight confusion always. And even when I was in college, I was like, okay, what is theta? What is omega? Somebody writes theta sometimes, somebody writes omega sometimes. What do you mean by all of that, right? Before that, let's just take an example of basic example that we were taking a little earlier also. For example, get sum. We are just trying to get the sum again, just like we were trying to do earlier. So can you guess what in this case the time complexity of this particular code would be? Now in this case the time complexity here would be, again, you have int sum of 0, return sum, so which is why a constant c2 that is always going to be there, because this sum is equal to 0 and return sum is always going to happen at least once. The number of operations is going to take so on and so forth, right? Again, you have a for condition wherein int I is equals to 0 happens once, I is less than n happens n number of time, because every time the for loop is running, it's checking that condition. I plus plus is happening n number of time, and this sum is equals to sum plus ARR of I is happening n number of times, right? So here we have a constant C1 multiplied by n. So in this case, you would have C1n plus C2 as the order of growth. But again, if you want to minimize it, the eventual order of growth would be n here. Right, now let's take another example in this case. So what if the code that we had changes something to like this, right? So here what you are doing here is the condition that is n percentage 2 equal to 0, then you are returning 0. So basically, when your number is even, then you are just simply returning 0. So we are saying, okay, always return 0 when your number is 0. Else, if the number that you've entered is odd, then give me the sum till now, whatever the sum of numbers till now. Let's say 7. So 1 plus 2 plus 3 plus 4, so on, so on. 5 plus 6 plus 7, right? So in this case, in the previous case, the order of growth would be constant throughout, because it's a very simple function wherein all the operations are going to happen always. However, in this case, there arise all the different cases, right? So for example, the best case in this particular case would be when your number is even, right? So for example, when your number is even, in that case, you are just, let's say your number is 4. So you are going to this particular condition, n percentage 2 equal to 0, and then directly you are returning and coming out of the function, right? So in that case, your order of growth is a constant, right? So that is your best case, that okay, if the number is even, I just don't have to even go to the for loop. Before for loop, the functions return something. Okay, now the average case would be now, or let's consider the worst case in this particular, or let's consider the average case, right? So the average case would be, let's say if this function is running over and over again and multiple times. So what would happen again? The probability of a number being even and the probability of number being odd is 50-50%. So one of those times it is going to take constant time, one of those times it is going to take linear time. Why linear time? Because the function for is linear in nature. Again, there are linear number of operations that are supposed to happen. So you can say that your order of growth, if you consider 50-50 equal opportunity, both of these cases, so you can say probably it's n by 2 plus c, or let's say c1 into n by 2 plus c2 is what you can say. Eventually your order growth after removing the leading constraints and the lower order growth numbers would be in this case n itself, right? So in that case, again, your order of growth in the average case is n. Again, you can say linear in this particular case. Again, when you consider the worst case scenario, so your worst case scenario is when your number is odd. Again, because never ever this n percentage to equal to 0, this loop will never ever get executed, and if the number is odd, always your for loop is going to run. So in that case, again, it becomes linear in nature. So now we found out there are, in this particular case, there are 3 different scenarios, right? Again, the average, the worst case, and then the best case. The best case is constant, the average case and the worst case are generally linear in nature. However, the average case is again better, because 50-50% probability of it being constant and linear. When you take an average of it, it becomes linear, right? So this is exactly what would happen in this particular scenario. If you just give me one moment. So There are different three types of asymptotic notations, which are big O, theta, omega. You may have heard about all of them at least once, but maybe sometimes are exactly confused in terms of what is the exact definition of all of these things, right? So again, big O represents your exact bound or upper bound. What do you mean by that? It says that, okay, if you say that the big O notation or big O is O of n, right? So in that case, you're saying that, okay, either it's going to be exactly n, or maximum to maximum is going to be n, O of n, right? So that's what you mean that, okay, or O of n square. So either it's going to be O of n square, or exactly, or at least lower than O of n square. So upper bound, maximum it can be that, not more than that, right? Again, theta is always like, it represents the exact bound. Exact bound is like always and always, doesn't matter what you do, doesn't matter whatever the scenarios are, always it is going to be exactly that. Now a few examples all of theta types of algorithm in this case are, uh, your merge sort, which is always n log n, your heap sort, which is always n log n, and your selection sort, which is always O of n square. So it doesn't matter if the array is already sorted, doesn't matter if it's in reverse sorted, doesn't matter it's randomly sorted, right? It is always going to be O of theta of n in that particular case, right? Now omega represents the opposite of a big O. So omega is like, okay, it represents the exact or lower bound. So we are going to say that, okay, at least it is going to be this, right? It may be worse than this also. So best case scenario, it is going to be like this, right? So omega is kind of like your best case, big O is kind of like theta is like to your exact case. So that's pretty much about all the three different notations that we have. Thank you so much. I'll see you up ahead in the next video.